So hello everyone, welcome back to my channel. So in this video we'll solve LeetCode problem 199, that is binary tree right side view. I'll explain what the question says. Here a tree is given in the question and it is saying that the observer is here. The observer is here and it is seeing the tree from right side. So what it will see, if it is seeing from the right side, what it will see, let me name all the nodes A, B, C, D, E, F, G, H and I. So what it will see, if I go from up to down, first it will see A, then it will see C, A, and in the next level it will see G, and at last it will see I. So understand what the question is trying to say. If the observer is viewing the tree from the right side, it will see all the first nodes from the right side, that is the rightmost node of each level it will see. You can see that's what written over here. So this is the answer that we have to return over here. So I will make this video, I'll solve this question in two parts. That is, in first part we will solve it in by BFS, that is breadth first search, and in second part we'll solve it by DFS, depth first search. So this is part 1 where I'll be solving this question with BFS. Okay, so before solving BFS, I would encourage that you can watch my previous video where I taught level order traversal using queue. In that I have taught regarding BFS. So I hope you have watched that video. If not, you can refer to that. So let us proceed with our problem. So you understand the problem statement, that what it is trying to say, and we are clear that we have to only find the elements which are rightmost in a particular level. Okay, so for better understanding, for like a dry run, I can segregate all the nodes level wise. Okay, so for level 1 I can say I can make a queue. Okay, for level 2, for level 3, and for the last level here. Okay, so here what I want you to understand the approach, that if I have a single element in the queue, okay, in the level, so I will simply pop out that and print or store anywhere, right? And if I have multiple, I'll pop out B. Okay, check, is it the last node in this level? No. I'll pop out C, check, is it the last node? Yes, it is the last node. So I'll store or print. Okay, moving on to the next level, I'll pop out D, is it the last node? No. Okay, continue. Pop out E, is it the last node? No. Continue. Pop out F, is it the last node? No. Still continue. Now I'll pop out G, is it the last node in this level in the queue? Yes, it is. So I'll store that or print. Then moving on to the next level, similarly I'll pop out H, it's not the last node, so I'll continue. I'll pop out I, is it the last node in this level? Yes, it is. So I'll print that or store. Okay, so this is how we're going, we will be proceeding. Okay, now I'll write the code and then we'll do a dry run. Okay, so before so this question is asking to return an array list of nodes, and in this tree all the nodes or the node value are unique. So it is saying that the return type would be array list of integer, because all the values are unique, integer. And I'll name this as solve, and the parameter given is root. The root of the tree is given in the parameter. Okay, ignore this. Okay, now we'll proceed. First of all, we'll initialize an array list. We'll make an array list because that is what we are the question is wanting us to return. So we will make an array list. Array list of integer. I'll name it as list, new array list. Okay. Now in the BFS we know simply if we have BFS, that means we will be using queue. Okay. So we will make a queue. Queue of what? Queue of node type. Okay. Queue of node type. Now do what? Name it like an object, a queue, new linked list. This is how we make a queue in Java. Okay, we have created an array list and a queue. Now I'll initialize it by storing the node by root in this queue. Okay, and as we have discussed that in BFS, till when we continue, till the queue does not get empty. So I've written not exclamation queue dot is empty. Okay, so till we have elements in this queue, we'll proceed. Okay, so since we are going level wise in this in the tree, I have told since we are going level wise, so first we'll take queue dot size because we are going level wise. Okay, so int n equals to queue dot size. This n means the number of nodes in a particular level. Number of nodes in the particular level means the size. Okay, here if I have like initially I have added that queue dot of a root, so the size is 1, we can say 1. Now when I'll put all the left and right node in the queue, the size will become 2, right? You can see over here. Similarly we'll proceed. I'll make a for loop int I equals to 0. I is less than, okay, focus here, I is less than n minus 1. Okay, why n minus 1? Because I know I have to add the last element, and okay, so these are not important for me, like these are not important for me. This node, these 3 nodes are not important for me, because what I want the answer, the last node, the last node, the last node. Okay, so that is why I'm running the loop till n minus 1. Then I'll write I plus plus. So if we are traversing till n minus 1, so we will simply poll, that is we'll pop out the node from the queue. Okay, pop off the node from the queue, and we'll check that if it has a left child, if node dot left is not equals to null, then queue dot offer, then that means add it in the queue. What? Queue dot left. Similarly for the right, similarly for the right child, if root node dot right is not equals to null, then do queue dot offer, that means add it at the right child in the queue. Okay, now simply I'll end this for loop, and as I ran this loop from 0 to n minus 1, still one node is remaining at that level. What node? The last node is remaining. So for the last node, I'll pop it out. I'll say node equals to queue dot poll. I'll say queue dot poll, and it is the last node. That means I want to store it in this list of integers, so I'll do list dot add node dot val, because the return type is integer. Here it is integer. Now but we have to check this as well. If it's if it has a left child, store it. If it has a right child, then store it. If node dot left is not equals to null, do queue do q dot offer node dot left, and if it have a right child, that is node dot right is not equals to null, then add the right child in it in the queue, node dot right. Okay, so with it I end this while loop as well. Here I'll end this while loop as well. Now at last I will return this list. Okay, so this is the entire code. You can see this is the entire code for this. Now I'll quickly do a dry run. Okay, so I have made a tree, and now we'll do a dry run. Okay, so I'll make a queue over here. Bigger queue. Okay, yeah. So initially I'll put a in it, right? That's what I did over here. Then I'll find out the size. The size is 1. I'll run a loop from 0 to n minus 1. N is 1. From 0 to what? Less than 0. Like, then this loop will not run. It will come to this, that now it will poll. It will pop out a and check, does a have a left child? Yes, it has. B. A has a right child, yet it has, that is C. And since it came over here, this part, that means I have to add it in the list. I'll make a list, add a over here. Okay, yes. Now the one time this ran entirely, then again queue is not empty. Okay, what size of queue is? Now it is 2. You can see it is 2. Okay, this level has been done. Now we are at this level. Okay, size is 2. That means it will run from 0 to 1. Okay, so that means one time it will run, right? One time it will run. So now it will pop out B. Okay, in this for loop, we are inside the for loop. It will check for the left and right child. Does B have a left child? Yes, it has D. B has a right child yet? Yes, it has D. Okay, we are complete with this for loop. We are over here. Now I'll pop out this C. I'll add it in the list. C is added. Okay, now check for the left and right child. Does C has a left and right child? Yes, it has. Then okay, push it. Okay, now we are done with this level. I'm at this level. What is the size? 1 2 3 4. Loop will I found out the size. Loop will run from, size is 4, so loop will run from 0 to 3. So for this node I'll pop it out. I'll check for left and right child. No, there is no left and right child. Okay, then pop out E. Check for left right child, yet it has H and I. Push it. Check for F. Okay, pop out, no left right child, ignore. Now I'm done with this for loop. I'm at here. I'll pop out this. I'm pop out the element. I pop it out. I'll add it in the list. G is added. Okay, G is added. Now check for left right child. There is no left right child of G. Okay, ignore. Now this level is completed. Now I'm at another level. What is the size? Size is 2. Size is 2, so loop will run from 0 to 1. That is one time it will run. I'll pop it out. Here it is. I'll pop it out and check for left right child. H has a left right child. No, it does not have. Okay, then ignore. I'm done with this loop. I'm at here. I'll pop out the element, add it in the list. I'll add it in the list. Check for left and right child. There is no left right child of I. Okay, continue. Now it will again return. It will come back here. It will check, is the size of queue is empty? Yes, the size of queue is empty. There is nothing in the queue. Okay, then this while loop will end over here, and we have the list over here. This is the answer, and we'll return the list. So thank you for watching. If any doubt, please drop it in the comment box. Thank you.